All right, number 4 is going to look like x divided by -5 plus 4 equals 3. All right, so I'm looking through my problem and I'm trying to find my variable. There's my x. Right now it's connected by a division of -5. All right, so I'm going to save that step for last. Okay, but I'm going to isolate that variable. All right, so in order to do that, I've got to get rid of the plus 4. Well, the opposite of addition is subtraction. So I'm going to subtract 4. This will create the 0 pair that I need to get rid of that 4. All right, but what I do to one side of the equation, I must do to the other side of the equation. So I have to go across the equal sign and do the same thing. So I'm going to take away 4 here. All right, so plus 4 minus 4 cancels out, creating a 0 pair. I'm going to rewrite my problem. X divided by a -5 equals. All right, on this side we have 3 minus 4. Okay, you have more negatives, so therefore I will have a negative value here. So that will give me a -1. All right, from there we are going to isolate the variable still. So the opposite of dividing by a -5 would be to multiply by a -5. So I'm going to multiply by a -5. Notice I am taking the negative with me. Okay, you don't drop the negative sign. You're just going to do the opposite of division. So this will cancel each other out, leaving me with just x equals, and then since I multiplied on this side, I must also do the same to the right-handed side of the equation. So I'm going to multiply by a -5. So a negative times a negative creates a positive. 1 times 5 gives me 5. All right, in order to make sure that that is true, we will go plug it in for x. So I'm going to rewrite my problem. X divided by a -5 plus 4 equals 3. Substitute the 5 that you found for your solution in for x. So I have 5 divided by a -5 plus 4 equals 3. All right, 5 divided by 5 is 1, but here notice you have that negative, so a positive divided by a negative is a negative. So I have -1 plus 4 equals 3. So -1 plus 4, I have more positives. I have 3 more positives actually. I can kind of flip that around and say 4 minus 1, and notice you will get 3 equals 3. So that is true. So therefore my answer that I found for x equals 5 is true. Box in your answer. All right, number 5. Number 5, we have 3x plus 4 equals x minus 5. All right, so I'm looking through my equation here, and I noticed something different about this equation than the other 4. All right, on this equation, I have x's on both sides of the equal sign. Okay, both sides of the equation. So what I'm going to have to do here is I need to make sure that I move my variables to one side of the equation. All right, and the rule of thumb is to always move the smaller variable. So what I mean by that is I'm looking at the coefficient. That is telling me that we have 3 x's. Okay, this x alone, standing by itself, has a coefficient. It's just not there. All right, and the only number that I can put there that won't change the value is a 1x. Okay, so there's really the number 1 there. So therefore, this x here has a smaller value. So I want to move this x to the left-handed side of the equation. Okay, in order to do that, I'm going to do the opposite of a positive 1x. So the opposite of a positive 1x would be to subtract it, or a negative 1x. So I'm going to take away 1x. All right, that cancels out on this side, making a 0 pair. Okay, here's my equal sign. What I do to the right-handed side of the equation, I must do to the left-hand side of the equation. So I'm going to come over here and I'm going to take away 1x. So 3x minus 1x gives us 2x. And then you're going to bring everything else down. So I still have a plus 4 to rewrite, equals, and I still have a minus 5 here. So minus 5. And notice here it was a minus 5, but down here it kind of turns into a negative 5. That's okay, it's the same thing. Okay, so now we have a normal problem with just one variable on the left-handed side. All right, so I want to isolate this variable. Right now it's connected to the 2 with multiplication. So I want to get rid of this plus 4. In order to do that, I must subtract 4. That creates a 0 pair, so I can cancel that out. But what I do to one side of the equation, I must do to the other. So over here on the right-hand side, I'm going to take away 4. All right, I'm going to rewrite everything. So on the left-hand side, I still have 2x equals negative 5 minus 4 creates a negative 9. All right, so here we have 2 times x equals negative 9. To undo multiplication, in order to isolate the variable, I have to divide. So I'm going to divide by 2. That's canceling out, creating a 1x, but I'm just going to write x equals what I do to the left-hand side of the equation, I must do to the right-hand side of the equation. So over here, I'm going to divide by 2. So you have a negative 9 divided by 2, which creates a negative 4.5, or negative 4 5/10. All right, now this one's going to be a little different whenever I go to check it, because I've got to plug it into 2 different locations where the x was. So over here, I've got 3x plus 4 equals x minus 5. All right, so I'm going to substitute the negative 4.5 in for this x. So we've got 3 times, okay, notice I'm using my parentheses to separate that group, negative 4.5, close parentheses, plus 4 equals. All right, and then over here, I have a negative 4.5 minus 5. All right, so I'm going to go ahead and work on the right-handed side because that's the easier side there. All right, we have negative 4.5 minus 5, so I'm going to have more negatives going on, okay? So that's going to give me a negative 9.5, or negative 9 5/10. All right, on the left-handed side, we are going to multiply according to order of operations. All right, so you have a positive times a negative, which creates a negative, and when you multiply that, you're going to get a negative 13 5/10 plus 4. All right, you still have to complete this step, so negative 13 5/10 plus 4 will give us a negative 9 5/10. And now you see that both sides are equal to one another. So check that off, you're good. So that means over here where we got x equals negative 4.5, I can box that in, that is a good solution.